Hello and welcome to G Fun Facts Online. Imagine a message in a bottle, not from across an ocean, but from across the galaxy, from a star system born long before our own. In 2025, astronomers caught such a message. It wasn't written in words, but in chemicals, carried by a visitor from interstellar space, a comet named 3I Atlas. Today, we're putting on our detective hats to join the largest interstellar forensics investigation ever conducted, decoding the chemical secrets of this ancient traveler and what it tells us about the cosmos. The story begins on July 1st, 2025. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, a network of telescopes scanning for potential threats to Earth, spotted something unusual. This faint object, initially just a string of numbers, wasn't following the rules. Objects in our solar system, like planets and our local comets, are gravitationally tied to the Sun, moving in elliptical orbits. But this new object was on a hyperbolic trajectory. Think of it like a slingshot. It will swing around our Sun just once, then be flung back out into the void between the stars, never to return. Its path had an extreme eccentricity, a measure of how much it deviates from a perfect circle, of about 6.1. For context, the first interstellar visitor, Oumuamua, had an eccentricity of 1.2, and the second, Borisov, was 3.4. 3I/Atlas is a true galactic wanderer. Initially, scientists weren't sure if it was a rocky asteroid or an icy comet. But just a day later, astronomers David Jewett and Jane Liu confirmed it had a fuzzy coma, a cloud of gas and dust boiling off its surface. It was official. We had our third interstellar object, a comet, designated 3I/Atlas. Immediately, the world's most powerful eyes, from the Hubble and James Webb Space Telescopes to the Very Large Telescope in Chile, turned their gaze toward this fleeting guest. The real detective work began with a chemical autopsy. As 3I/Atlas gets closer to the Sun, its ices turn directly into gas, a process called sublimation. By analyzing the light passing through this gas cloud, using a technique called spectroscopy, scientists can identify the exact chemical fingerprints of the molecules being released. And the first major clue was a shocker. Observations from the James Webb Space Telescope revealed that the comet's coma was overwhelmingly rich in carbon dioxide, or CO2. In our own solar system's comets, water is the star of the show. It's almost always the most abundant volatile. But in 3I Atlas, the ratio of carbon dioxide to water was measured to be as high as 8:1, and in some analyses, an incredible 19.5:1. This is the highest CO2 to water ratio ever seen in any comet, by a long shot. What does this mean? One leading theory is that 3I/Atlas formed in an exceptionally cold part of its home star system, far beyond the carbon dioxide ice line. This is the region where it's cold enough for CO2 to freeze solid. Its home might have been much colder than the birthplace of our own comets. Another idea is that the comet's ices have been blasted with higher levels of radiation during its long journey through the galaxy. A third possibility is that something about the comet's structure is trapping heat, preventing the less volatile water ice from sublimating as easily as the CO2. While water ice and vapor have been detected, their surprisingly low abundance remains one of the central mysteries of this object. Just as astronomers were grappling with the CO2 puzzle, another strange clue emerged from the Very Large Telescope in Chile. They detected nickel vapor in the comet's coma. Now, finding metals in comets isn't totally unheard of, but they almost always appear alongside a proportional amount of iron. They're cosmic cousins. But with 3I/Atlas, there was a significant amount of nickel, with a strange and surprising lack of iron. This unusual nickel-to-iron ratio sent ripples through the scientific community. The leading explanation is as fascinating as it is exotic. Scientists propose the presence of a highly volatile molecule called nickel tetracarbonyl. This compound forms when nickel reacts with carbon monoxide. As the comet gets sunlight, this fragile molecule could be breaking apart, releasing nickel atoms into the coma. What makes this so intriguing is that, until now, nickel tetracarbonyl has really only been found in industrial manufacturing processes here on Earth. This led to some wild headlines about alien technology, but scientists are quick to emphasize that this is likely a brand new, previously unknown natural chemical pathway happening in the cold, strange environments of interstellar space. The discovery of nickel vapor so far from the Sun, where it's incredibly cold, was also a surprise in itself, suggesting this process is highly efficient. The forensic analysis didn't stop there. The chemical cocktail of 3I/Atlas is complex and revealing. Cyanide gas, a common component of comets, was detected in concentrations similar to what we see in our own solar system comets, providing a familiar baseline. The JWST also found carbon monoxide, but its ratio to water was more typical, around 1.4, unlike the extreme CO2 ratio. Adding to the list is carbonyl sulfide, a smelly gas that gives scientists another data point to reconstruct the chemical environment where this comet was born. And it's not just gases. Observations have also looked at the solid bits being thrown off the nucleus. They've found abundant grains of water ice mixed in with the gas, and the dust itself has spectral properties similar to D-type asteroids. These are reddish, carbon-rich asteroids, suggesting 3I/Atlas is loaded with organic compounds, the building blocks of life as we know it. So what does this unique chemical fingerprint tell us about where this comet came from? By combining its composition with its trajectory, astronomers can trace its path backward in time, trying to find its home. And this leads to perhaps the most profound discovery of all. The high velocity of 3I/Atlas suggests it has had a very long journey through the Milky Way. This has led some astronomers to propose that it's not from our local stellar neighborhood, but from the thick disk of our galaxy. The Milky Way has a thin disk, where our Sun and other young stars reside, but surrounding that is an older, more diffuse halo of stars called the thick disk. If 3I/Atlas came from this region, it could be more than 7 billion years old. Our entire solar system is only 4.6 billion years old. This would make 3I/Atlas the oldest comet ever observed, a pristine sample of material from a much earlier epoch of our galaxy's history. We aren't just studying a piece of another star system. We might be studying a piece of the galaxy's past. The discovery of 3I/Atlas is also critical because it's our third data point. Science thrives on comparison, and now we have 3 interstellar visitors to compare. The first, 1I Oumuamua in 2017, was a complete enigma. It was cigar-shaped, appeared rocky, showed no cometary activity, yet accelerated away from the Sun as if something was pushing it. The second, 2I/Borisov in 2019, was much more familiar. It was an active comet whose composition looked almost identical to the comets from our own Oort cloud. It suggested that maybe comet formation is pretty standard across the galaxy. Now, 3I/Atlas arrives and seems to bridge the gap. It's clearly an active comet like Borisov, but its chemical makeup is bizarre, with its high CO2 and strange nickel signature. It's different from our comets, but in a way that's scientifically explainable, unlike the lingering mystery of Oumuamua. It shows us that there isn't just one type of comet out there. The chemical diversity of other star systems might be far greater than we imagined. The investigation is far from over. As 3I/Atlas makes its closest approach to the Sun in late October 2025, it will heat up even more, and astronomers will be watching intently to see what other secrets boil off its surface. More observations are scheduled with Hubble and the JWST after it rounds the Sun. While the peculiar nickel finding has fueled some speculation about extraterrestrial technology, much like the debate around Oumuamua, The scientific community is focused on the incredible natural discoveries being made. These unusual chemical signatures are opening up new chapters in astrophysics and astrochemistry. 3I/Atlas is a fleeting gift from the galaxy. The cosmic detective story unfolding through our telescopes is revealing that the building blocks of worlds can be wildly different from one star system to the next. It's a testament to the sheer diversity of the cosmos, and as the data continues to pour in, it will undoubtedly reshape our understanding of how planetary systems, including our own, form and evolve. The Interstellar forensics team is hard at work, and the final verdict on this ancient traveler is yet to be written.